ramming in mandrel. A few things I want to go over with everybody is what's right, what's wrong on ramming in a mandrel. You know, if I took a single dial indicator and put it out here, I had a couple thousandths, I'd tap it around and get that zeroed in. But what about this end? Oh, I made this mandrel in this chuck, in this lathe, and I marked my chuck, and every one of my mandrels is marked on that jaw. And you would think you could just throw it in there and it would be exactly perfect, right? But you know, this lathe is an old wartime antique. It is in pretty good shape for an old lathe, but there's no such thing as perfect, especially on stuff that's this old. I also always tighten on that one. I marked this lug as tightening it. I done a lot of testing when I first got this lathe, and by tightening this lug gave me the best repeat setup. If I tighten my part up using this lug, you know, it might be 3-4 thousandths out of true, and maybe this one as well. And by tightening this one, I was within 1.5 on average, and it tended to repeat. But it doesn't always repeat, right? So I can't just trust that. So I use 2 dial indicators, and you know, as you can see, I'm rotating the chuck, and I'm about 2 thousandths out. Now I could start tapping that around, correct that, but I'm about 2 thousandths out on this one as well. And they're talking to each other, meaning they're both, I'll stop turning it, they're both very close. I don't have a wobble in it, right? See how they agree with one another, right? So what I'm saying is that the arbor is going in and out evenly. It's not doing this number, right? So when I put the cylinder on it, the cylinder will go, you know, back and forth like this, but the base will still be cut square. If it was wobbling like this, then the base ain't square. Now, to go into this a little further, do I really need a precision-made mandrel? What if I took anything that fit inside the cylinder, just so it fits in there and sits on a squish band, right? Just something that fits the squish band. Doesn't have to be, you know, a real close tolerance to the cylinder. Maybe even a piece of square stock. Anything, right? And I stuck it on there, and all I done was face off the face of it so that it's flat and square, right? Slide my cylinder on there, put my tailstock up against it, put some pressure on it, right? Even though none of this touches the cylinder wall, doesn't have to. And I tighten it up to that. As long as that squish band is square, in theory, it will cut the base square, right? So every time I do this, you know, I take the time. Now I just slammed this one in there, and this is exactly how it came. you know, so it's true, other than it's 2 thousandths. The chuck is 2 thousandths out one way. However, it's still square. It's still square. For the process that I'm doing to cut the base on the cylinder, it's going to cut the base square, and it doesn't have to be trammed in for any other reason. You know, I could knock it around, you know, but this is why I use 2 dial indicators to do this. I'd like to be dialing here. However, when I made this, I do this end and this, you know, the whole piece is reversed, and I machine these 2 surfaces first. Then I turn it around, I put it in here, and I machine the rest of this, face this off and everything. So there's a, you know, this isn't going to be perfectly true to this. It's close enough, but it's not perfect, right? So this is how I do it. You know, if there's some very wise machinist out there who wants to tell me how I'm wrong, they're more than welcome to tell me how I'm wrong. But you know, the further apart these are, the more accuracy you're going to have in it. But you know, I can only get so far to the edge because I've rounded these edges off. You know, I've done some machining in here, so I got to stay on this main surface that was all machined and polished when I made this thing in the first place. But I think I'm right about all you need, as long as the squish band is square. If you can sit on 4 corners or 75% of that squish band, and the squish band square, I don't see why it won't work. But I make a nice mandrel. I've got them for every size. Mandrels and cutters. I turned my old set of mandrels into cutters from my old lathe because they absolutely don't work on this lathe. So, and I've been playing with mandrels and cutters and a little bit different ideas on those. But lots of mandrels, you know, fit all the saws, and still every once in a while I run into one I don't have, and I just make another one. I got really lucky, and I bought like 20 feet of bar stock. Didn't know the grade of the steel. They were drops or remnants, and I bought 3 of them. None of them were over 8 feet, but quite a bit of it for like $40. Very, very cheap at the time, so I decided to use it for this, and it's worked out great so far. But you really don't need, you know, anything good. I wouldn't use like Delron plastic, whatever, because if you change your tension on here, and how hard can you squeeze Delron, it'll start to warp and move and not be right. And the other thing was, people talked about a long time ago, was an expandable mandrel. And I don't know much about expandable mandrels, but what do you tram it off to? How do you dial it in? I wouldn't have a clue. But these are polished down till they'll just slide on the cylinder. There's not much room there, thousandths or 2, and a little more, you know, whatever it takes to get the cylinder to slide on there. Every once in a while I get a cylinder that's a little bit tighter, and I got to polish it some more. But I try to do it quite accurately because, you know, I have to do this. So anyways, we're going to throw this on there and set it up, and this is that 500i cylinder. And you know, you guys talk about you know, somebody cut squish band crooked, whatever, you know, and it's tramming up your lathe is where your issue's at. You cut something crooked, you know, cut your base crooked. You know, if a base is cut crooked and the cylinder can tip forward or backwards to the crankshaft, right? It ain't gonna hurt anything. It's when it tips side to side that puts your rod bearing, everything in a bind. So it's important, you know. But I don't know, I think this works. I made saws with heads, you know, 2-piece heads like this. Now, if you wanted to cut something off the base of that, how do you hold it? Well, that's what this hole's for. That's tapped, threaded. That's where there's a port. And I put a screw down a plate through a port, you know, down through a port. Whichever port I can get into, it doesn't really matter. You know, this would be a lot easier to get into this one. And then I can bolt that in there, and I can cut the head off right on a mandrel. You know, so that's the machining of doing head saws like that. So you can do a head and you can get the head square, right? So then you need a pretty good snug mandrel, but it'll tighten up down on one side fairly well. If you're trammed in good, take light cuts. It doesn't move around very much. Of course, it can still move some because it's not 100%, right? You didn't press it in there, so but keeping the mandrel very tight to that cylinder and drilling a hole in it, tap it. Don't take it out until you're finished with your job. You know, I mean, you can make a mandrel specific for one cylinder if you wanted to, and then you could use Delron or whatever if you really wanted to. I think. Well, maybe because you're not using a tailstock for cutting the head off, right? I still don't think I'd use Delron. Chunk of aluminum, you know, anything you can get your hands on will work. And again, you could probably use a square stock and just nip the corners off until it's just slid on there, and you know, find a place to put a screw and then just put a plate or a washer or whatever right over the port and screw it on there. Doesn't take too much thought to get it right. It is important to get these right, you know. But years ago, 044s, 034s, you know, 064s, they didn't have a machined squish band in them. They were just cast. And boy, you know, they weren't square to begin with. So, let's say you were running a fairly loose mandrel and you faced this off and you slid it up there, chances are you're going to cut it, well, however far off the squish band is. You know, if the squish band is crooked, you're going to cut the base crooked. And even with this, you know, this cylinder can move on there a little bit. Let me get rid of these out of our way here, and I'll slide the cylinder on there. You know, if I'm up here, You know, I can wiggle that around, get down further, you know. It wiggles and it turns on there. It doesn't wiggle a lot, you know, but a little. But I know that my mandrel is square. I know that my squish band is factory cut square. It should be square enough. Tighten that up. We're running here on nothing more than friction between the cylinder head squish band and the top of the mandrel. You know, that's what we're working with, right? Back this up. I've got another indicator. I don't know if I can get it in here now, but see how far I can move this. I've got another indicator, but this isn't accurate. This is really old. I got it at a like a barn sale, garage sale type of thing. So it runs around on there, pushes on the lever, pushes up on here. And I'm not going to say this is accurate, but I got a little tension on it. I push it in, push it out. The other thing is that this bar has one of these adjustable, and this itself is loose. See what I mean? It moves here, wiggles here. This is not the right setup for this process. This should be a solid bar. Take some of the wiggles out of it, but you know, it doesn't even try to wiggle, right? I want to replace this dial indicator. It's really old. There's no glass in it anymore. But I think this piece will go on any indicator, but it has to be a short throw indicator, right? And I need a solid shaft in here. And with a new indicator, I think this would all indicate really well. But like I said, this thing isn't very accurate of an indicator with all the playing around I've done with it. Usually if it's off, I can see it wiggle at least, right? So someday I'll invest in this, but it's just something I don't need or use very often, and I just stumbled upon it at a little garage sale, and I grabbed it. You know, just the indicator and this is really all I got. Didn't have no stand or anything, but I had a stand that had a solid shaft in it, and I have no idea whatever happened to it. But I've got indicators all over the place. I've got, you know, there's 2, 3, 4, 5 on this lathe. Got another lathe over there on the other side of the shop. I usually got an indicator or 2 over there. So, anyways, you can't do this work without the proper knowledge, proper tools. It's awfully important, and people, you know, they think, oh geez, you know, I can just take I saw one guy, he made a little wooden box to put the cylinder in, and he used his wood router to cut the base. I put a little tension on my lock. Set up another indicator down here. Right, so I'm on my way, and I got a little spot there. I stick it on, kind of in that area, and then we'll fire this up. I just get, you know, I'm not touching it yet, but I get out here a little ways. I don't want to touch too much, but I'll start the lathe up. I'll move this over until I just start to touch just a little bit. That's a couple thousandths. And then I set this to 0 and I start cutting some off. Always got to think about your clearance. Gotta think about clearance. So you don't want fins, anything, nothing hitting, right? And this is partially the stick out of my bit is, for that extra, reach, right? We're cutting aluminum. We're not cutting a lot. I generally cut 30 thousandths off of these. So I'll take 28 thousandths on the way in and 2 thousandths on the way out. Seeing it's an interference cut, rigidity is what you really got to have. You got to make sure you got everything tight, whatever, right? Tights, it take as much air and stuff out as you possibly can, and then you're going to have some flex always, right? So an interference cut, that flex isn't consistent. It's on and off and on and off and on and off. So you're better off to take a very, very light cut as a finished cut. So generally I'm going in 28 thousandths on my way in, and then on my way out, I just dial in a couple more thousandths and cut it on the way out. And that's part of the idea of this grinding that I do, is it cuts both ways. And I'm running converter. I got rid of my broken belt. I was going thump all the time. It's a nice lathe. I like it. I run a pretty good, fairly fast speed for this lathe anyway. There's lots faster out there, but we're running around 312, whatever that says. And I think it's fast enough for this. Right there, I'm just touching. Yeah, it's probably like 2 thousandths, but I don't worry about that. I'm going to set this dial to 0, zeroed out. Make sure it settles down. Like I said, I don't like these wobbly shafts. I don't like these gizmos. Maybe someday I'll just find some chrome shaft or something the right size, stainless. This isn't really fussy either, I'm just trying to get about 28,000, that's all I'm looking for. Something like that. Okay, we're kind of snug here. We are in forward gear and we'll let her go. It's a second for my clutch to catch up. It's got a little slop in it. okay? In here and pump it up. Lift and pulse. We'll get in reverse. And back out. And we're just touching a little bit, you know. And seeing it's an interference cut, because it's a square, it's got holes in it, all that kind of stuff. Then, you know, this takes any of that waviness or whatever you want to call it that's caused from the interference cut with deflection of your tool. And I'm not a machinist, but, you know, I figured this shit out. You know, I got a couple friends that are machinists. I talk, you know. Nice and smooth. That's what we're looking for. Right? I like to see it nice and smooth. Now, I don't leave it smooth, or not glass smooth. Right now it's glass smooth. I do base gasket delete, and when I delete it, and I use Durco sealant. You know, there's other sealants out there probably does a little better job, maybe. For sealing, it's a little more rugged, right? Anyways, you know, cameras show a lot of things that aren't there. Always have. You know, this is just like a piece of glass. Anyways, there's always a chance that that it can slip through on a very smooth surface. So I've got a little sanding block, flat sanding block that's flat, sandpaper on it. I got some fairly coarse paper on it, like 60 grit or something. And I just rubbed this a little bit, just to have a few little light lines in there to give it something to stick to. And on some saws, I put in a groove all the way around to work like a O-ring groove or whatever. And then it can't pull that Durco in out of there either. I could do it to this one, but I don't really have to, you know. Some of the 661's got a long distance between the bolts. It's quite long, and they tend to start to leak right in here. And so I go ahead and cut a ring in those, and that helps keep them from leaking right there, just because of this distance. Flex of the motor when it's running, you know, it'll start to leak there. This isn't as bad, you know. But yeah, I do that more and more on more of the saws all the time. Now it's gonna go. I gotta clean that all up, but it'll go back on. And I got my alignment screws in here. Just do 2, and then I can use 2 regular screws for checking my squish when I get there. And that's the next project, is setting up a mandrel. This is the wrong one, but this adjustment tool goes on every one of my mandrels. It's 2 pieces. It's threaded. This one clamps on. It's not threaded into this mandrel. It clamps on a smooth surface. But these 2 are threaded, and each line on it is 2/1000. A friend of mine made this for me. It was his pattern, his idea. This is all made out of tool steel. Nice piece. It works extremely well. I don't remember what he said the thread pitch was, but every mark is 2/1000, so I can just loosen this, turn it, tighten it back down, drop it down 2/1000, and cut it by hand. That's how I've done it for years, and I'm not going to change my method. It works so well for me. I don't know why I would change. Now, there are some guys that make up a square plate, and they use it in a Ford jaw. And I put it in here, put the cylinder on, so, you know, it's open on this end, the cylinder, putting the head up here, and they're running bolts through, and they got to get that all trammed in and lined up, and it has to be about as perfect as you can possibly get it trammed in there and to cut the squish band on a lathe. And if you don't have that right, you're gonna cut a crooked squish band. But that goes back to, like I said, the old saws. There's an old 28 maybe. I guarantee you that 28 does not have a machined squish band in it. And I checked squish for years and on those old saws, and it was no big surprise to see one that was 8/10,000ths out of square, because it was just a casting, and they all had a little ridge, you know, trying to point here with a screwdriver, but they all had a little ridge over here on this edge, you know, right in here, from when they bored it, right? And they didn't bore it all the way to the top and do the squish band. They just bored it far enough, and they'd leave a ridge in there. And, you know, you didn't do anything with that ridge, you really couldn't do a whole lot of dropping a cylinder. So what some of the guys used to do, and I done a couple that way, but it's not really the right way. But to get away from that ridge, you put a little notch in your top of your piston here, just so this piston couldn't catch the ridge, right? Ring might get up close to it, but you put a little notch in here, right in this corner. Just take some of this corner out, so it wasn't catching the ridge that the manufacturer left in there. That was kind of commonplace, along with pop-ups and all that kind of stuff was all kind of commonplace, you know, back in the day. But if you think about it, you know, like I said, I just took 30 off of that. I'm going to take, you know, base gasket's getting deleted. That's getting deleted. They're about 18 or so, you know, 18, 20. And then, so, you know, I'm dropping them, you know, a rough idea here is 50,000ths, right? You cannot cut 50,000ths off that. You cannot do a 50,000ths pop-up just by cutting a piston. And so, you know, most guys would do like a 25 maybe thousandths pop-up. That's probably only worth 5 to 10 pounds of compression, that pop-up. That's really all it's worth. And a lot of machining, a lot of screwing around to get that little bit of that little bit of compression, because once you cut the piston back, you know, the only port that changes in doing all of this work, doing a pop-up, is the intake port is lower. But seeing you're cutting the piston back down, it puts the exhaust and transfers right back where they were. So you have more options by doing it this way, and you have a much higher compression increase by doing it this way. So that's the benefits of cut band squish, is more benefits, more options, and the piston's not machined, so someday when you need to replace the piston, you can just throw a stock piston right back in there. And you're right back to what it was. You don't have to go find a machinist to make you a new piston, especially if the porter you saw is no longer doing it or no longer around. Just kind of how them things go, you know. All of my saws the work is there. All the work is there except on Huskies. Most of the 3 Series Huskies, I do some work in this area of the skirt to help open up the lowers, which is, at most anybody can repeat it as long as they copy exactly what I did for width this way. You don't want to open up the port windows. You know, you don't want to get into the, cutting around here enough to get into the port window or to sit there. It'll change your port timing. So I don't know, I'll talk about some more little things on and off as I go through all of this. I'll talk about, porting and port durations and port time area, mean port time area. Fun stuff, knowledge. You don't understand things that I'm talking about. Likely you shouldn't be porting a saw. You should be studying motors and studying books and, books. Lots of information. Now, this stuff doesn't pertain to chainsaws specifically, but there's a lot to learn about what everyone's talking about. When I start talking about port time area, mean port time area, primary transfers, secondary transfers, which ones are they? You know what I mean? Nobody understands what I'm talking about, and they should. They really truly should, because I can confuse people and make them look at me funny right real quick, because I know all of these definitions and I know what this stuff means, and I understand it and I get it. And if you don't understand it and get it, you're guessing. You're just flat guessing. So anyways, that's it for this one. We'll get on to the next one. Till the next one.